Hi everyone, welcome to my channel. This is my first video and I'll be covering all the topics under analog devices. So let's go straight into the topic. My first topic is diode. What is diode? As name suggests, di plus ODE, it means it has two electrodes. What are those two electrodes? One is electron and one is holes. So these electrons are negative charge carriers. That means the electrons carry negative charge, and these holes are positive charge carriers, which means that holes carry positive charge. So diode simply is said to be having two electrodes. One is electrons and another is holes. So it has both positive and negative charge. So if you check on with the definition, it is diode is a two-terminal bipolar and unidirectional semiconductor device. So what is this two-terminal? See, if you check on with the symbol, this is the symbol of diode. So one end is anode and another end is cathode. Anode, cathode. Anode is positive, cathode is negative. So diode has two terminals, anode and cathode. So that's what it is mentioned here. What is bipolar? Say if any device conducts current due to both electrons and holes, then it is called as bipolar device. If any device conducts current only because of either electron or hole, not both, either it will be due to electrons or holes, then it is said as unipolar. Here in diode, current flows due to both electrons and holes. That's why it is called as bipolar. Then what is this unidirection? In diode, current flows only from anode to cathode. In reverse direction, the current will not flow. So diode allows the flow of current only in one direction and opposes the flow of current in another direction. So that's why the diode is called as unidirection. Now these are the definitions of diode. Let's move on to construction. Yes. So construction is very simple. You need to join two layers. One is P layer and another N layer. What is this P layer? Is P-type semiconductor. And what is this N layer? Is N-type semiconductor. You need to join two semiconductors of P-type and N-type. So when you join P-type semiconductor and N-type semiconductor together, it gives diode with a junction in between, and that is called as P-N junction. So this diode is also called as P-N diode because it simply consists of P and N layer. What is this P-type semiconductor consists of? It has maximum number of holes, that is positive charge carriers, and minimum number of electrons. N-type semiconductor consists of maximum number of electrons, that is negative charge carriers, and minimum number of holes. Now how can we draw this? Again, anode. So P-type semiconductor consists of maximum number of holes, which is represented as plus sign, and minimum number of electrons, which is represented as minus. Now there is a junction in between. Now n-type semiconductor consists of maximum number of electrons, which is represented as minus, and minimum number of holes, so I'll represent it as plus, and another end is cathode. Yes, see, now let's check in for the operation. Here if you see, we know opposite poles attract each other. So here positive sign, and this side there is maximum number of negative. So what happens is that they both attract each other. When they attract each other, there happens a recombination of electrons and holes at the junction. See, now this is the semiconductor. Since opposite poles attract each other, electrons move towards p-type and holes from p-type move towards n-type. So what happens is that they both recombine at the junction. So I'll just mention it in this way: the recombination of electrons and holes at the junction. Okay? Yes. Okay. So now, since recombination is done already, it becomes neutral particle or neutral ion. Here you have maximum number of holes. This side you have maximum number of electrons, and at the junction there is neutral ion where the recombination of electrons and holes is carried out at the junction. Now what happens next? See, we know weight of electrons is greater than weight of holes. Hence, speed of holes will be higher comparatively because the weight is very much less, so it can move faster. So speed of the hole is high comparative to the electrons. So anode and few are already recombined as neutral ion. This side is cathode, this is P layer and this is N layer. Now there is a neutral ion at the junction. Now see, because of change in movement of speed of electrons and holes, electrons will move slower from n-type to p-type, but holes will move faster from p-type to n-type. Due to this mismatch in the speed, few of the electrons I'll explain you. Few of the electrons will get settled here and few of the holes will get settled here. This is happening because of the mismatch in the speed of both electrons and hole movement. There is a deposition of electrons at p-type junction and deposition of holes at n-type junction. Now this completely is known as depletion region. The construction is very simple. You have to combine both p-type and n-type. So p-type has maximum number of holes and n-type has maximum number of electrons. Here the opposite poles attract each other and they recombine. They start combining and they will form a separate layer at the junction, and that region is known as depletion region. Now see, when electrons try to move towards the holes, or if holes tries to move towards the electrons, they get repelled, because when electrons are moving this side, these electrons are of same poles, so they'll attract. So this can't cross the junction. Again, holes, it cannot cross the junction because it gets repelled because there is a holes here. So further movement of electrons and holes get stopped. So remaining electrons will stay here and remaining holes will stay here, and there is no movement further, and at that point there comes a potential difference, and that potential difference is known as voltage barrier. Voltage barrier. So this is the voltage which is caused at the depletion region. For silicon, if you say, you will have 0.7 volt as a voltage barrier, and for germanium it is 0.3 volt. So this is all the construction, and you can tell what happens next. So next is working, or you can simply tell operation of PN diode. See, here the movement of electrons and holes gets stopped permanently, and there is a depletion region where one side has electrons, other side is holes, and in between it is a neutral particle. So this you can also call it as battery, because one end is negative and another end is positive. One end is negative and another end is positive. Yes. So this depletion region can also act as a battery. Okay. Now let's go into working in what we have to do for the movement of electrons and holes, because here the electron and hole movement is stopped completely. So in order to further make the movements of electron and holes, you have to give an external voltage. So, or you need to bias the device. How you will bias the device? You can do it in two ways. One is positive bias, or you can say forward bias, or reverse bias. First I'll explain you what is forward bias. See, forward bias is nothing but you need to connect p-type, n-type, p-type to positive and n-type to negative. So this is as simple as that. For forward bias connection, you will be connecting p terminal, or you can also tell anode to positive of the battery and cathode to the negative of the battery. So what happens here is that, wait. Electrons. This is n-type, this is depletion region. Now this is n-type and this is t-type. This t-type is connected to positive of the battery, and this n-type is connected to negative of the battery, and this is simply called as forward bias. So what happens here is that you are giving an external voltage supply. Now here you have maximum number of holes, and here this is a positive voltage supply. So what happens is that these holes get repelled from this positive supply. It will not get attracted because the like poles repel each other. So here also maximum number of holes, and here also it is positive voltage supply. So what happens is that it will repel, it will move away from this voltage supply. So these holes will try to move towards n layer, crossing the depletion region. Now here maximum number of electrons are present. These electrons will get repelled from this negative voltage supply, and it will cross the depletion region and it will move towards the p layer. So when voltage is applied, see here, say if it is silicon, the barrier voltage is 0.7 volt. That 0.7 volt is actually stopping electrons and holes from moving further, from recombining. This 0.7 volt is stopping. So when you apply the voltage till 0.7 volt, there is no current flow. So till 0.7 volt, there is no current flow, the current is 0. When applied voltage is less than 0.7 volt or barrier voltage, you can call it as barrier voltage, current is 0. When the voltage external exceeds this barrier voltage or 0.7 volt, then the current starts flowing. So when current flows, the recombination of electrons and holes takes place. So that's why the PN diode operates in forward bias condition and current will move from positive to negative, hence the current flows in this direction from anode to cathode or from P layer to N layer. First, when you apply an voltage, there is no current flow. Yes, because the 0.7 volt barrier voltage is stopping the movement of electron and holes. So when this applied external voltage exceeds this barrier voltage, then the maximum number of current flows, and this is in the direction of anode to cathode. So I'll explain you with simple graph. So this is 0 in forward bias condition. So starting when you increase the voltage, it will be equal to 0 because it is less than external voltage. So when you increase the voltage at 0.7 volt, the current starts increasing. So till 0.7, no current flows, and once the external voltage exceeds 0.7, the current flows through the diode from P layer to N layer. So that's everything about forward bias condition. Next is negative bias. How diode will work when it is in negative bias condition. So there is a p-type layer, depletion region, and n-type layer. In positive bias condition, P layer will be connected to positive of the battery and N layer will be connected to negative of the battery. Here it is opposite, where P layer will be connected to negative of the battery and N type will be connected to the positive of the battery. That's the difference. So let's see how it operates when it is connected in this way. Here the battery has negative polarity and here majority is holes, which is positive. So what happens is that these positives holes will get attracted towards the negative of the battery because opposite poles attract each other. So all the majority carriers, that is holes in p type, will get attracted to the negative of the battery, and this side if you see, majority is electrons and these electrons will get attracted towards the positive of the battery. So now we can redraw it. Plus will get, holes are getting attracted. This is depletion region. Yes. Here if you see, I have redrawn because holes got attracted towards the negative of the battery and electrons will get attracted towards the positive of the battery because opposite poles attract each other. So minority charge carriers are left as such. Now what happens here? Say now you will be applying in external voltage V external, and say you are using silicon. Still the barrier potential is 0.7 volt. So when you apply an external voltage till 0.7 volt, no change will take place because this 0.7 volt, which is a barrier potential, is actually stopping the movement of electron and holes. So when you apply external voltage 0.1, 0.2, 0.3 till 0.7, no changes will take place. Electrons and holes will remain as such and no current flows. So when external voltage becomes greater than 0.7 volt, current will flow, but because of this minority charge carriers which are in less number, so current will flow in very less quantity, which is called as leakage current. So we are plotting it in reverse bias. So it is reverse bias condition. Now what happens is that when you are increasing the current, voltage till 0.7 volt, only small amount of current flows. This is small amount of current, which is called as leakage current, and once it reaches 0.7 volt, the current will flow. I'll explain how. Till 0.7 no current will flow, and once it crosses 0.7 volt, because of the movement of minority charge carriers, small amount of current will flow, that is called as leakage current. And still more increasing the voltage, still more you are increasing greater than 0.7 at higher level, large amount of current will flow, which breaks the junction. Because there are only few number of electrons and holes, so what happens is that because of that few number of electrons and holes, small amount of current will be flowing. But what happens when you increase voltage still more, large amount of current will flow, and hence it damages the depletion layer, or it damages the junction, and that process is known as avalanche breakdown. Hence, we will not use the diode in reverse bias condition, because applying the voltage to the greater level will break the junction and it will damage the diode. That's why the diode is only used in the forward bias condition, and current will flow in only one direction. So this is all about the working of diode in forward and reverse bias condition. If you want to make the diode work in reverse bias condition also, then there is a separate diode called Zener diode. So we will see that in the next class, and also the applications of diodes. Yes, I'll put a video next time. Hope everyone understood the concept of diode. If you have any comments or suggestions, please let me know. Thank you for watching the video. Like and subscribe my video if you like it. Thank you.